Good morning, students of 6th semester 2017-18 batch of Faculty of Agriculture, BAU Ranchi. One course allotted post-harvest management and value addition of fruits and vegetables. Under this course, today I am going to deliver very important topic, jam, jelly and marmalade. Now we will see what is the difference between jam, jelly and marmalade. Jam is a product made by boiling fruit pulp with sufficient amount of sugar to a reasonably thick consistency, firm enough to hold the fruit tissues in position. Apple, pear, sapota, peach, papaya, karonda, carrot, plum, strawberry, raspberry, mango, tomato, grape and muskmelon are used for preparation of jam. It can be prepared from one kind of fruit or from two or more kinds. Jelly. A jelly is a semi-solid product preparing by boiling a clear strained solution of pectin containing fruit extract. It is free from pulp after the addition of sugar and acid. Now qualities of jelly. What should be the quality of jelly? These are needed. A perfect jelly should be transparent, well set but not too stiff, and should have the original flavor of the fruit. It should be of attractive color and keep its shape when removed from the mold. It should be firm enough to retain a sharp edge but tender enough to quiver when pressed. These are the qualities of good jelly. Guava, sour apple, plum, karonda, wood apple, locust, papaya and gooseberry are generally used for preparation of jelly. Fruit having low pectin can be used after addition of artificial pectin powder. Marmalade. This is fruit jelly or jam in which slices of the fruit or its peel are suspended. The term is generally used for products made from citrus fruit like orange and lemon in which shredded peel is used as suspended material. Citrus marmalade can classified into jelly marmalade and jam marmalade. Jelly marmalade. Combination is given different type of combination for jelly marmalade. Sweet orange, malta and khatta or sour orange in the ratio of 2:1 by weight. Shade of malta orange peel is used. Mandarin orange and khatta in the ratio of 2:1 by weight. Shade of malta orange peel are used. Sweet orange malta and gulgal in the ratio of 2:1 by weight. Shade of malta orange peel is used. And jam marmalade. In case of jam marmalade, it is same as that of jelly marmalade, but here the extract, pectin extract of the fruit is not clarified and the whole pulp is used. Sugar is added generally in the proportion of 1:1, cooked till total soluble solid content reaches 65%. Now preparation of jam. And before preparation, I would like to say what is the difference between jam, jelly and marmalade. Jam is nothing but it is a product made by boiling fruit pulp with sufficient amount of sugar to a reasonable thick consistency. But in case of jelly, pectin from the fruit which is found in the middle lamella, pectin is first extracted and boiled with sugar and acid, and then this jelly formation takes place. So in case of jam, we can use only one fruit or mix many type of fruit, and it can be fresh fruit, frozen, dry, any type of fruit we can take for jam preparation. Only to a thick consistency we have to boil. But in case of jelly, at first we have to extract the pectin and it is boiled with sugar and acid, and then the pectin, then the jelly formation takes place. This is the main difference. And in case of jelly, only fresh and one kind of fruit is taken. And marmalade is jam or jelly of mainly citrus fruit having shredded of citrus peel suspended in its body. This is the main difference of jam, jelly and marmalade. Now preparation of jams. In its preparation, about 45% of fruit pulp should be used for every 55% of sugar. The FPO, fruit product order, specification of jam is 68.5%, TSS 45% of the fruit pulp, and acidity in terms of citric acid 0.5 to 0.6% per 100 gram of the prepared product. Now, what is the protocol? At first, selection of and preparation of fruit. Good quality ripe fruits are selected. Wash the fruit well in cold water. Peel the fruit and remove the stone and cores present. Cut the peeled fruit into small pieces with stainless steel knife. Stainless steel knife because to avoid any metallic contamination. If the fruit is hard, it should be cut into very small pieces. Pulp the fruit using pulper. Addition of sugar and acid. Cooking the mixture. Slowly with occasional stirring, the fruit pulp should be crushed with wooden ladle during cooking, and continued cooking till a temperature of the mass reaches to 105.5 degree Celsius. Sheet or flake test. A small portion of the jam is taken out during boiling in a spoon or wooden ladle and cooled slightly. It is then allowed to drop. If the product fall off in form of a sheet or flake instead of flowing in a continuous stream or syrup, it means that the end point has been arrived, and the product is ready. Jam is ready. Otherwise, boiling is continued till the sheet test is positive. Next step is packaging and filling the hot jam into clean, dry, sterilized, pre-sterilized jars. Allow the jam to cool and fix the sterilized lid to the jar. Storage is done in a cool and dry place. Now, problem in jam production. Crystallization is a problem observed in jam. The final product should contain 30 to 50% invert sugar. If the percentage is less than 30, cane sugar may crystallize out on storage, and if it is more than 50, the jam will become a honey-like mass due to the formation of small crystals of the glucose. Corn syrup or glucose may be added along with cane syrup to avoid crystallization. Sticky or gummy jam. Because of high percentage of TSS, jam tend to become gummy or sticky. This problem can be solved by addition of pectin, citric acid, or both. Premature setting. It is due to low TSS and high pectin content in the jam and can be prevented by adding more sugar. Surface graining and shrinkage. It is caused by evaporation of moisture during storage of jam. In a cool, dry place, when it is stored, this problem is rectified. Microbial spoilage. Jam should be stored at 80% RH. Mold growth can also be prevented by covering the surface of jam with a disc of wax, paper, and addition of 40 ppm SO2, 40 ppm sulfur dioxide in the form of potassium metabisulfite, KMS. These are not a serious problem due to high sugar content. This is flow diagram of jam. We have already discussed that ripe fruit is taken, washing, peeling, pulping, addition of sugar, boiling with continuous stirring, judging of end point at 105.5 degrees Celsius or 68% TSS by sheet or flake test, filling into hot sterilized bottle, cooling. This is waxing, capping, and storage at ambient temperature. This is the flow diagram of jam. Now, preparation of jelly. For jelly preparation, pectin is a very important substance. Pectin present in form of calcium pectate and responsible for firmness of fruit. Pectin is the most important constituent of jelly. It is commercial term for water soluble pectinic acid, which under suitable condition form a gel with sugar and acid. In early stage of development of fruit, the pectin substance is water insoluble protopectin, which is converted into pectin, that is pectinic acid, by the enzyme protopectinase. During ripening of fruit, in overripe fruit, due to presence of pectic methyl esterase (PME) enzyme, the pectin gets largely converted to pectic acid, which is water insoluble. This is one of the reasons that both immature and over mature fruit are not suitable for making jelly. Only ripe proper ripening stage are used. Sugar. This essential constituent of jelly imparts to sweetness as well as body. Color is also arrived due to charring of sugar. Inversion of sugar. When sugar, sucrose, is boiled with an acid, it is hydrolyzed into dextrose and fructose. The degree of inversion depending on the pH and duration of boiling. This is the formula all we know. Just for repeat, I'm given degree Fahrenheit minus 32 by 9 equal to degree Celsius by 5. Theories of gel formation. How this jelly is set? What are the theories behind this phenomenon? The first is fibril theory. Fibril theory was proposed by Crues, and it was according to this theory that when sugar is added to pectin solution, it destabilizes the pectin water equilibrium, and the pectin form a network of fibril, hold the sugar solution in interfibrillar space. The firmness of network depend on concentration of sugar and acidity. One type of network is formed by the pectin, and the sugar solution is embedded in the network, and thus the jelly is prepared. Now, second one is Spencer theory. Pectin particles are negatively charged. A pectin solution is most stable at neutral pH, thus increases in acidity and alkalinity, decrease the stability of pectin solution. In jelly formation, sugar acts as a precipitating agent, and the presence of acid help in it. Olsen theory. Pectin is taken to be a negatively charged hydrophilic colloid. Sugar acts as a dehydrating agent which disturbs the equilibrium existing between water and pectin. If the negative charge on pectin is reduced with the help of proton H plus concentration, pectin precipitates in the form of a network of insoluble fibers, provided that the sugar is present in sufficient amount. The rate of hydration H plus and precipitation of pectin increases with the addition of acid in direct proportion up to an optimum of about pH 2. Last theory is Hinton's theory. Fourth one is, it assumes it is contradictory to other theories. It assumes that pectin are complex mixture of variable compositions. Gelations of pectin are a type of coagulation in which the coagulated particles form a continuous network. It is only the non-ionized, not the ionized pectin, which enter into jelly formation. According to Hinton, these are the non-ionized particles which enter into the gel formation. Now, determination of pectin content. How this pectin is determined in the any fruit extract? Alcohol test. In this method, very easy method it is, involving precipitation of pectin with alcohol. 1 teaspoonful, 1 TSP is equal to about 5 gram, and 1 tablespoonful is about 15 gram. 1 teaspoonful of strained extract is taken in a beaker and cooled, and 3 teaspoonful of methylated spirit are poured gently down by the side of beaker, which is rotated for mixing and allowing to stand for a few minutes. If extract is rich in pectin, a single transparent lump or clot is formed, and in this case a equal amount of sugar is to be added. If extract contains a moderate amount of pectin, it shows less firm and fragmented clot. and in this case 3/4 amount of sugar is added, means 750 gram in 1 liter of pectin extract of fruit. Now if the extract is poor in pectin, numerous small granular clot will be formed, and in this case 1/2 of the amount of sugar is added. Another test is gel meter test. Gel meter is a simple instrument based on the principle of viscosity. The gel meter is held in the left hand with the thumb and forefinger. The bottom of the gel meter tube is closed with the little finger. The strained extract is poured into the gel meter with a spoon simply and held in right hand till it is filled to brim, up to the brim, up to the mouth. While still holding the gel meter, the little finger is removed from the bottom line and extract is allowed to flow or drip exactly for 1 minute, at the end of which the finger is replaced, and the reading level of the extract in the figure indicates how many parts of sugar to be added. Very simple. The gelling of extract depends on the amount of acid and pectin present in the fruit. Of the 3 acids, citric, malic and tartaric acid found in fruit, the final jelly should contain at least 0.5%, preferably 0.75%, but not more than 1% of total acid, because a larger quantity of acid may cause syneresis or whipping jelly. pH of extract. Jelly strength increases with the increase in pH until optimum is reached. The optimum pH for jelly containing 1% pectin, which is optimum, is approximately 3, 3.2 and 3.4 for 60, 65 and 70% TSS. In general, the optimum pH value for jelly is 3.2, corresponding to 65% TSS. Judging of endpoint. Boiling of jelly should not be prolonged, because excessive boiling results in greater inversion of sugar and destruction of pectin. If a jelly is cooked for a prolonged period, it may become gummy, sticky, syrupy and deteriorate in color and flavor. The end point of boiling can be judged in following ways. These are the methods. Sheet or flake test, already we have discussed. Temperature test, it is done by using simple processing thermometers. A solution containing 65% TSS boils at 105 degrees Celsius. This is the principle. Drop test. A drop of concentrated mass is poured into a glass containing water. Settling down of a drop without disintegration denotes the end point. Flow diagram of jelly preparation. This is simply, already we have discussed, processed fruit, firm, not overripe, washed. It is cutting into thin slices, boiling with water 1.5 times with the weight of fruit for about 20 to 30 minutes. Addition of citric acid during boiling, 2 grams per kg of fruit. Straining of extract. Pectin test for addition of sugar. Then sugar is added. Again it is boiled, and end point is judged by sheet, drop or temperature test. Removal of scum or foam. When if it comes, then 1 teaspoonful of edible oil added for 45 kg of sugar to remove this scum or foam problem. Addition of color and remaining citric acid. Filling hot into clean sterilized bottle, then waxing with paraffin wax, capping and storage at ambient temperature. Important consideration in jelly making: pectin, acid, sugar 65% and water are the 4 essential ingredients. Pectin test and determination of endpoint of jelly. These are the very important in terms of quality of jelly. Now, problem in jelly making. Failure to set. It may be due to addition of too much sugar, cooking below the end point. This failure to to set the jelly, this problem comes, and it can be rectified by the too much sugar. If it is too much sugar, then sugar is added in proper amount and end point is judged at proper end point. The product is cooked. These are the recommendations. And then cloudy or foggy jellies. It is due to use of non-clarified juice or extract, use of immature fruit, overcooking, non-removal of scum or foam. These are the main causes of cloudy or foggy jellies. Premature gelation. Excess of pectin in the extract causes premature gelation, with the result that air may get trapped in the jelly and thus make it opaque. It can be avoided by heating the solution to boiling point and immediately pouring into containers, using low concentration of sugar. Low means optimum, using a slow setting pectin, not using acid during cooking. These are the methods. Syneresis or whipping jelly. Syneresis and whipping, very pertinent term with jelly, very important term. It is nothing but spontaneous exudation of fluid from the gel is called syneresis or whipping. It is caused by several factors. Exudation takes place continuous and it shows that the jelly is whipping. Like excess of acid. It causes breakdown of the jelly structure by hydrolysis and decomposition of pectin. Insufficient pectin, it can also cause, and accordingly this problem can be solved. And fermentation. Although a high percentage of sugar, 65%, prevent ordinary fermentation, it can take place in jelly if syneresis occur. Storage of jelly in a damp place, even if covered with a seal or paraffin wax, favor the growth of mold. The growth may be due to several reasons: not covering the jelly properly, not pouring sufficiently hot paraffin wax. These are the breaking of paraffin wax seal. Hermetically sealable glass jars are used to avoid this. Hermetically means airtight sealable glass jar, and cans are used to avoid the problem. Preparation of marmalade. Already we have discussed that in case of marmalade, it is jam or jelly of citrus fruit having fine shades of citrus peel suspended in its body. It is a fruit jelly in which slice of the fruit or peel are suspended. The term is generally used for the products made from citrus fruit like orange, lemon. Already we have discussed. And this is the ingredient: 1 liter of sugar, 750 grams for 1 liter pectin extract, 750 gram of sugar is added, and shredded peel in the at the rate of 62 gram per liter of pectin extract is added to the produce. Problem in marmalade making. Browning during storage is a very common problem in marmalade and can be prevented by addition of 0.09 gram of KMS per kg of marmalade and not using tin containers. Causes metallic contamination. This is flow diagram for marmalade. Ripe fruit is taken, washed, peeling outer yellow portion flavido thinly, cutting yellow portion into fine shades, 1.9 to 2.5 cm long and 0.8 to 0.12 cm thick, 0.45 cm cutting of 0.30 thick slice of peeled fruit or crushing into pulp in a grater. It is done. Now it is boiled in 2 to 3 times its weight of in water for 40 to 60 minutes. The extract is extended and then pectin test is done. Cooking to 103 to 105 degrees Celsius by continuous stirring. Addition of shredded peel boiled for 10 to 15 minutes in several batches of water for softening and removal of bitterness, and added at the rate of 62 gram per kg of extract. It is the main point. Boiling till continuous stirring, and 80 to 88 degrees Celsius tested for end point. While continuous stirring, flavoring is done and stored at ambient temperature. This is the depiction of jam, jelly and marmalade. Here we can see that jelly is somewhat one type of fruit or many type of fruit having thick consistency. Jam is clear. This pectin extract boiled with sugar and acid, and marmalade, it is jam or jelly of citrus fruit having suspended shades of peel of different type of citrus fruit. Now this device is hand refractometer, very useful to estimation of total soluble solid, TSS. TSS is the measurement of sweetness of any fruit, vegetable or any commodity. This hand refractometer, and here we can see that one or two drop is poured in this chamber, and it is then seen by eye, and one tabular form bricks is displayed, it can be visible by eye, and it is based on the principle of refractive index. Now this is all about jam, for jam, jelly and marmalade. Thank you very much.